So what exactly, why we are talking about scooters nowadays? So we inspired from the car actually. So what we learn in the previous attacks on the cars. So there are a lot of news around world. So talking about the hacking, Kia, Hyundai, they make multiple kind of the keys, and they try to start the cars. And there are something called as they usually use the mobile application, and they reverse engineer the mobile application. These mobile application expose a lot of vulnerabilities of the cars, and there are a lot of things are there. Like the famous one is the Jeep attack in 2015, and Charlie, the name of the researcher, he controlled the entire car remotely in that case. So why we are talking about e-scooters? So if you see, the e-scooters are, I'm talking about with respect to the Indian market. So as per AI, that is ChatGPT and Bard, they say, and even this is the true actually, till August 2023, we have 1.3 million electric scooters in India. And 2030, it's going to be 10 million scooters. So I'm talking about only in India. I'm not talking about Vietnam or any Asian countries or Europe or everywhere. So why this kind of initiative is going on in the entire world? As per Indian thing is rising fuel prices. Yes, there's a huge fuel price in the India. Government incentives, and then increasing awareness about the environment benefits and electric vehicles, growing demand for personal mobility solutions, and improving technology and performance of electric scooters. So these are the reasons. That's why this market is growing. And as I said, I'm talking about India, and India is highest in population. We cross China. So you can say how much population we have in India, and we are using scooters now. So, and why electric scooters are going to be famous? Because of some features. If you see over here, like the live vehicle tracking, geofencing, anti-lock, anti-theft alert, service alert, navigation assistant, lot of features are coming into the e-scooters now. So why? It's the same like a car nowadays, like a Tesla or VinFast, or a lot of companies are coming with the electric car with a lot of features. The same way the electric scooters are coming with a lot of features. So I would like to introduce myself. My name is Arun Mane, and I'm a serial entrepreneur. I'm a founder and CEO of Amynasec Research Lab, Amynasec Labs as well, and co-founder for Uno Academy. I'm a researcher and trainer as well. Apart from this entrepreneurship, I train people for hardware hacking, vehicles, IoT, and industrial control systems. I'm also a speaker at multiple conferences around the world. And this is my Twitter, or X, you can say. And this is my LinkedIn. I used to come with this style, not like a suit, actually. So, okay. So what exactly the components and the typical architecture of the scooters? Scooters have different kind of, if you see over here, Lightning, BMS. BMS is like a battery management systems, onboard charging, power distribution unit, side stand, cluster. There are a lot of things are there which come up with a different aspect. It's actually a typical thing. So what exactly inside the things? They have motor, MCU, and CVT, final gear, and the ECU with engines. So they are connected to each other, and ECU main decides everything, like a VCU in that case, vehicle control unit, and they talk each other with the help of CANBUS. So we'll go in detail in the next slide. So if you see the exact architecture for electric scooters, there are two comes into the picture. One is single ECU system architecture. Is nothing but it's handled with a one and only ECU that handles entire process of the scooter. So here you can say temperature sensors, and then stand sensors. If you stand the scooter, it's automatically stop the engine. And battery backup, it's nothing but the BMS, battery management system. Vehicle speed, then fuel sensors and gyro sensor. There are a lot of things. It's controlled by only one body control unit. Is nothing but one VCU in that case. That controls everything. So there are something architectures come up with a advanced feature. As I said, the scooters are going into the different altogether. They add a lot of features in the scooters. So they have, if we are adding features, definitely you're going to add electronics. Electronics you added, that means we are going to deal with ECUs. So multiple ECUs architecture system. In that case, you will see the infotainment system. It's separate infotainment system with a different variety. In that case, they have different operating systems like Android OS or modified Linux version. So, and that's come up with a GPS, GSM module. In that case, they use eSIM or the physical card in that set. And they works on they also supports Bluetooth in that case. So this is typical ECU. It's nothing but an infotainment system, and they have DC to DC converter, which converts your, when you charge in the vehicle, like battery management system, that's convert DC to DC, which converts 48 volt to 12 volt. So usually the CANBUS communication supports 12 volt in that case. So there are different kind of CAN IO. CAN IO is nothing but CANBUS input output. In that case, there are different kind of messages associated with the CANBUS communication. So lamp load and powertrain motor control and mirrors, these are entire things handled in a different ECUs with the help of different ECUs. So let's talk about CANBUS, what exactly the CANBUS it is. I'm sorry I'm going fast because it's a 30 minutes talk and we're already late. So this is the typical thing, CANBUS, and we have arbitration ID 11-bit or 1129-bit as well. It's different on the what exactly kind of CAN A, CAN B or CAN FD they are using. And this is the DLC, that is data link lead, and this is data and CRC field and end of frame. So entire this chunk is the frame of the CANBUS and how they communicated. So it's typically you will find in every automotive, like in the car architecture as well as in scooter. So it's nothing but all ECUs are connected on the one line. So one line, it's a two-wire communication, CANBUS, CAN high and CAN low. So in that case, all ECUs are connected to each other and they broadcast message, or you can say atomic message. So they send the message on the CANBUS communication, and every ECU listens that communications, and depending on what exactly the action defined or even defined in the CANBUS communication or CANBUS, and they react on that. So this is very important to understand what exactly this time frame between the two consecutive messages. So this is it's really help for the reverse engineering of the communication part actually. So if 1 second, 500 second and 250 seconds, so less second, milliseconds is 250. So 250 message, if you see the message which transfer at the rate of 250 message, that means a high priority message. So what is high priority message? Can you tell me someone what exactly the high priority message in the scooter? Braking, right? So yeah. So as per safety standard, braking is the most important, right? So we'll going to understand why I'm talking about the braking in that case. So braking and the engine start, engine stop, and even some certain kind of like when you talk about the cybersecurity in the automotive, they also talk about the safety security, like in the safety standards. So the safety standards and cybersecurity nowadays walk hand by hand or side by side for share the knowledge. What happened if there is a very good example? If the brake fails, electric car brake fails, what happened? how they solve that problem. So they should have a mechanical brake instead of, right? So they have some mechanism they need to implement in such a way that electric brake get disabled or get affected or someone attack on that. So mechanical, right? Mechanical brake should apply. So it's the standards 626243. So in that case, so 250 millisecond defines the highest rated priority message, then 500 and 1 second. So when they develop any vehicle or automotive parts or ECU, they define the CANBUS bandwidth. So define the CANBUS bandwidth. That means how many messages they want to develop, number of messages, and based on the number of messages, they calculate these timing frames. So that timing frames, because in the entire body structure, like EE architecture, we call it as, in the EE architecture, they calculate each and every bandwidth for every messages. So that's how they develop. It's a very short and simple story about that. So what are the tools you can use? There are plenty of tools available in the market. So ValueCAN 3 is the one of the good, I would say, from Interpret. This is the PCB board. It's USB tin. So it's cost around I think so, around $35. And this one cost around like $300 to $400. And this PIC can, we usually use PIC can over here. So it's cost around $250 to $300. So there are different ways to do intercept the communications. The CANBUS communication will show you how we can do that actually in that case. So when you have the car or scooter in that case, so what the first step we do actually, we try to understand what exactly the CANBUS message and what the messages are for which event in that case. So we call it as a CANBUS reverse engineering. So in that case, what we try to identify first, CAN high and CAN low. So imagine we have, this is scooter, right? We have scooter over here and they have wires, nothing but we call it as a harness in the automotive industry. So these, let's say these are harness and we try to identify what exactly. We are going to do a physical attack to understand the communication. So we need to find out CAN high and CAN low wires, right? In that case. So wires can go from the front end, back end, wherever it's possible, you have to find the wires. And once you find the wires, you need to identify the CAN high and CAN low in that case. So here, as I said, CAN high and CAN low in the electric scooter. So we'll show you usually where you can find that thing actually. So after that, once we found the CAN high, CAN low, you have to use one tools like this one, USB tin or PIC can, and you need to find out their CAN high and CAN low, and we have to connect with over here CAN high and CAN low. And once you connect, you use different kind of tools, software tools or CANBUS tool or CAN utils, you can say. It's a Linux version utility. So and then you have to intercept the entire communication and we have to find what exactly the communication is going on. Once we know the messages are going through the entire scooter, so now we need to find out what event is associated with what kind of message it is. So in that case, what you will do? So you attach the wire, CAN high, CAN low with your laptop. Then you try to press the brake. So when you press the brake, in that case, the message pop up, right? Indicator, message pop up. And a lot of things you do when you ride the scooter, message pop up. So based on that, you specifically identify these kind of message is associated with that. So what we understood, it's the battery low message. So in that case, all electric scooters whether the scooter is in any country or India, they pop up message for the user information that is battery low, right? So if the batteries get low, then you have to charge, right? So what? The battery low, that means it stops. So that is the functional or safety mechanism for safety mechanism for electric scooter. They don't want to burn the battery in that case, right? So they have to show the battery low. Then there are some safety and functional related to messages we identified. So in such a way that any event happens, it's adversely affect on the entire scooter. That is the biggest problem. Any cybersecurity researcher or hacker can take advantage of it. Speed, we identified what exactly the speed and motor safety messages. So some message get pop up, and because of that message, the entire engine get killed, right? So these are the messages. There are a lot of messages because we don't want to disclose some sensitive information about the scooter. And this scooter is, we are not going to talk about any OEM or something. We already shared this detail with OEM, and OEM is really proactive and they rectify everything. But still, as we promised with our OEM, we are not going to disclose anything about the scooter name or any manufacturing unit or something. So what kind of the attacks we performed on the scooter, like replay attack, we just record the message and send it out. That we did. Forge CANBUS injection, and we modify some messages in the over the CANBUS, and we send, and we saw some abnormal behavior on the scooter. It's exactly. We also fudged entire message IDs. So arbitration ID in that case. So here, as I said, these are the arbitration ID, two numbers, 3 numbers. These are the arbitration ID, and these are the milliseconds between 2 consecutive messages. So we try to find out the arbitration IDs, and based on these arbitration IDs, we perform fuzzing attack on the scooters itself. So we also perform DOS attack in such a way that the message get killed, and because of that, infotainment system and the machines, or you can say the entire CANBUS communication get jammed. Bus off attack we performed because of different kind of it's an error message developed in the CANBUS standards itself. With the help of this error message, we can perform bus off. That triggers that it stops the entire communication between the entire scooter. So in that case, this is the main line for the CAN high, CAN low. It's main. It stops entire communication. It's kind of DOS attack. We can say the DOS attack, but it's a CANBUS implementation flaw actually in that case. But it's not flaw as automotive people say, but it's flaw. We are hackers. We take advantage of it. Error passive spoof attack we perform. So these are some messages. These messages not look like hash. We deliberately put hash because we don't want to disclose any message IDs for this. So some message IDs, like as I said, battery low, right? So battery low, that prevents the motor starting. So if you start the motor, if I use this particular message and send on the infotainment system, it pop up the battery low message, and the entire machine get low, or rather you can say you cannot start the engine in that case. So this is for safety purpose, but it's not validated in such a way that if someone spoof that message or send those kind of message or first, it gives the adverse effect on the scooter itself. Same like turn off vehicles. So repeatedly sending those message, it's turn down the vehicle motor and turn off the entire vehicle, right? Then scooter issue going on to halt. This particular message, if we send, so it shows the scooter issue going to halt and the entire engine get killed. Same, this one is interesting by modifying this result. It's motor abruptly turn off the vehicle. So these are the different kind of messages we identify. We identified a lot of messages with respect to infotainment, CANBUS, and telematics. We are not showing over here. It's related to this talk is related to CANBUS, but in next conferences we are talking about the entire scooter vulnerabilities and everything. So what is hardware implant attack? So you reverse engineer everything, this thing, how we can control the scooter now. So we want to do with like movie style, right? But the demo is not like movie style, but you can imagine in that case. So hardware implant attack is nothing but we are making the hardware we kept inside the scooter. So how we kept and what is the cost of the hardware. So we'll come to know. We open this is my company's logo. So we don't want to show anything, what exactly the scooter name or manufacturer. So we open, you can say over here. So we open front side. We open the front side. We use Arduino and we use ESP32 and the one MCP 2551 chipset, which is CAN transmit receiver. So we attach everything and attach with Arduino because there is a problem with the 5 volt and 3 volt in that case. So we need to identify this thing, and remotely over the Wi-Fi we control. You can use the chipset which can work on the 4G or 2G or 3G. You can do it and you can remotely control same thing. So this is the hardware and we kept inside over here, and we have the power bank over here. So the good part is in this scooter we have USB already, which gives 5 volt and 3 volt. So we attached our Arduino and it's running up and running over there, and we use extra power bank, and the entire setup is like up and running. It's cost around like $15 entire cost. And this looks like this, the entire scooter and the entire setup. You can crunch the entire setup in different way always, right? So we can crunch and we make it in the $5 as well. So depending on how you going to do these kind of setup or chipsets in the market, and you can use it. So let's see when the scooter is in the motion, where I was driving in our lab, my office lab, and it get killed. So let me pull the video. Wait. Okay, this is the interface we made with the help of MQTT or online server. With the help of MQTT, so we are showing some messages. And in the lab, I was driving the scooter, and we started the attack. And boom, you can see the headlight. It's not working at all. So if you accelerate, so it stopped. Right? So this is how we can control the entire setup. So we in this thing, so you can see over here, this thing is open, and you can put the devices over here and you can control. Yeah, sure.
You see that the same kind of attack
yeah. Yes.
So, for example, because you said it's a different system with the GSM and so on.
Yes. Yes, absolutely. There is a way to attack external without open this thing. This is talk related to, anyways, you have to reverse engineer the entire vehicle, right? So you have to connect your device physically, and you understand the message. That's the one thing you have to do. And after that, you can modify your messages from the outside with the help of your fake BTS or fake eNode B in that case, and you can inject those data. So we did some of attacks. We cannot disclose as of now, but the entire thing whatever is happening, as I said, there's a one single ECU architecture and multiple ECU architecture. They are connected to each other. So in the advanced, the smart cars, they come up with the gateways, next generation gateways. So X gateway, or these gateways are nothing but firewall for them. So as of now in the scooter, there is no gateway at all. If they put the price of the scooters get high, right? So that's the issue. But this is the viable solution, you can say that. So in this stationary mode, so you will see I would like to answer that question. The infotainment is really connected. You can see that. So now we are showing this. This is the setup we have, and this is infotainment. And this is wireless communication. And then you can see we perform, it's off. The entire scooter was off because of that particular message. And we hide the name of the manufacturers. That's why we stick the paper over here. And I'm starting the engine now. Okay, I'm pressing power button, and once the press the power button, because it's already shut down, and after that you can see the infotainment is restarted. That's you can see the lines coming on, right? Sorry, I cannot show the manufacturer's name. I'm repeating one again and again because this video is going to be seen by OEM. Anyhow, so this is how we did. It's asked for passcode, so we punch the passcode, and then after that you can see the infotainment system is up and running. So why it's happening actually? So because the implemented this safety, they are implemented as per my understanding. It's not the way it should be actually. The way it should be like a car, right? So they take care of the safety, but they should take care of safety with the cyber security in that case. So what happened, they're definitely taking care of the safety of the security with respect to user or pedestrian. But in that case, what happened? We, hacker, researcher, anywhere, if they know, they can take advantage and they can stop scooter when you are on the highway, right? So that's what happened exactly. So yeah, so I would like to tell everyone that you, from researcher around the world, or hackers, or any kind of guy you really want to understand, they should concentrate the motorcycle or electric scooter nowadays. Yes, the car is very important, and this scooter is also very important because it's a huge market. I'm talking about the Indian market because I'm not talking about Asian. Asian have a lot of scooters and a lot of things. So if the huge market for Indians, definitely for other countries also, it's a huge market. Need to address cyber security of e-scooters that's e-scooters getting smarter and smarter day by day, or you can say the year by years. That would I say. E-scooters are secure. This is a myth actually. No, it's not at all. E-scooters are secure. No way. So this is the example we shown over here. So there are a lot of things they need to improve. They need to put cyber security in the standards. So they have to take initiatives in that case. Hire external automotive cyber security experts to test those devices, and again they should come up with called as intrusion detection systems for scooters, and gateways for firewall or gateways. I'm giving the example of car or vehicle in that case, but they should come up with this idea. Maybe in the future some of people or manufacturer comes with these kind of ideas in that case. So any question? No?
Thank you, Arun. I don't think we have too much time for questions, but I'm sure you are going to be around the conference, so everyone can stop by and ask
sure.
additional questions. Thank you so much.
Thank you.